We'll be looking at the general characteristics of myeloid and lymphoid growth factors. We've already had a video where we actually listed this myeloid and lymphoid growth factors. Okay, I hope you guys have watched that video. All right, so here we are basically talking about their characteristics, how they behave in general. Okay, so coming in here, you guys could see the hematopoietic stem cell, which can either divide into the common myeloid progenitor or the common lymphoid progenitor. Okay, so basically talking about the lymphoid, the growth cells that will act on the lymphoid side and the growth cells that will act on the myeloid side. They basically have general characteristics that are alike. Okay, so common myeloid progenitor, common lymphoid progenitor is just like that. All right, and the rest of the cells that are dividing from this, all right, you guys already know the hematopoiesis pathway, mustn't be stressing over it. So what are their characteristics? We said that they are glycoproteins that act at very low concentration, right? So all these are glycoproteins and they don't really need high concentrations to act. They can act at very low concentration. They act hierarchically. What does that mean? It means that every step, is it divided into erythrocyte? There are different combinations of growth factors that are needed. Is it divided into megakaryocyte? There are different categories of growth factors that are needed. Is it divided into the T lymphocyte? There are different classes of what growth factors that are needed. You understand? Then they are usually produced by many cell types. They usually affect more than one lineage. For example, you have the interleukin 2 acting here. You can find the interleukin 2 acting here too. You can find the interleukin 3 acting here. You can find the interleukin 3 acting here too. Okay? I hope you guys are following up. They are usually active on stem and progenitor cells on differentiated cell, right? They can be active on stem cell, they can be activated on progenitor cells, and they can be activated on what? They can be active on differentiated cells. All right, so they usually show synergistic or additive interactions with other growth factors. All right, that's why I told you guys that there's a combination. They can act hand in hand. Do you understand? You'll be like, okay, guy, you are acting on neutrophils. Okay, I'm acting on neutrophils too. Let's join forces. Do you understand? They show synergistic or additive interactions with other growth factors. They often act on what neoplastic equivalent of a normal cell, right? So if the normal cell is becoming neoplastic too, if the normal cell is becoming cancerous too, they can also act on that cancerous cells to actually promote its growth, okay? So they have multiple actions like proliferation, differentiation, maturation, functional activation, prevention of apoptosis of progenitor cells, okay? These are their various functions, right? So this is a proper image without the growth factors, proper image showing the process of hematopoiesis, where the hematopoietic stem cells divide into the myeloid progenitor cells and the lymphoid progenitor cells, and the rest of the process continues. All right, so guys, that's it, and I'll be seeing you guys in the next tutorial.